On today's lesson, we're going to talk about volumes of pyramids and cones. So we need two new formulas, one for each of these shapes. The volume of a pyramid formula is not that complex. It's actually 1/3 area of the base times the height. Remember that big B is area of the base. And remember that height is the piece that goes from the center of the base straight up. Sometimes they won't give you that height. Sometimes they'll give you this piece over here, which is called the slant height, which we represent with an L. And then we have a little right triangle that we'll occasionally use, depending on what we're needing to find. That's a good skill to be able to have. We can go ahead and do example 1 right down here because it gives us a lot of good information. However, this one is tricky if you don't remember some old stuff. What I first want you to do is just forget about this right here, because this is part of the solution that they're trying to help you on. We're going to do it from scratch, that way you can do the whole process. This is all they're going to give you on this type of problem. You need to realize that you have a hexagon on the bottom. So make a quick sketch of a hexagon, and then we know that that side length is 4. But we have to find the area of that shape. The formula for that shape is area equals 1/2 ANS. What does A stand for? Apothem. What does N stand for? Number of sides. And S is side length. So we know some of those already. We know our side length, it's 4. We know our number of sides, it's 6. We do not know our apothem. But what we should remember is that if you put a center on this shape, and then you draw a radius and the apothem, which goes to the middle of this side, you've then created a little right triangle. That's the right triangle I'm going to enlarge so we can discuss it in more detail. Now that I've enlarged it, can you label this side, the short one? It's 2. How do we get that? We do 1/2 of 4. This side going straight up, what's it called? It's called the apothem. This piece right here is the radius, but since that's not in my formula, I'm not going to really worry about it. I'm just going to deal with 2 sides. I can also find my angle. How do you find that angle? Yeah. 360 divided by number of sides. That's our central angle. And I'm pretty sure it's 72. However, you got to divide that by 2 because we're not doing the whole angle right there. Oh, sorry, 60. My bad. And 60 divided by 2 is 30. I'm thinking of another problem. So that's a 30-degree angle right here. Now, you have 2 options whenever you see that you have a 30, 60, 90 triangle. You could use special right triangle formulas, or you could use trig. I'm going to maintain that trig is a little bit more powerful, a little bit more versatile, so let's practice a little bit more trig. We're going to label real quick. Here's my angle. This piece is opposite of my angle, and this piece is right beside it. This is called my adjacent side, so that's still going to be A for adjacent. O and A, whenever we're dealing with trig, is going to be tangent, T-O-A, SOHCAHTOA. Tangent of 30 equals O over A. Do we know our O? It's 2. Our A is just A, and then we're going to cross multiply. Now, cross multiplication tricks up some people. Usually people are good at the first step, which is the easiest. 2 times 1 is 2. And then you do your other cross. What's the other cross going to be? Tangent of 30 times A. Now here's the problem. Some people start guessing at what to do from here, but you should think of this mathematically. This thing is multiplying by A. How do you get rid of multiplying? We got to divide by the term we're trying to get rid of, which is tangent of 30. Divide by tangent of 30 on each side. So they'll cancel on this side. We're just left with A now. And on the other side, this is exactly what we type in. 2 divided by tangent of 30. 3.464 is what I heard, and we'll go with that. That number right there is what we plug in for A, 3.464. 3.464. If you type all this in, 1/2 times 3.464 times 6 times 4, you will get your answer. I'll give you a second to try that. All right, we get 41.568, and put your units on it. Those are inches cubed. Inches cubed as our final answer. Now, I did stop a little bit early. This piece is just our area. So we have to do a little bit more because we're trying to find volume. We're kind of celebrating a little bit early. However, this goes in for big B. So volume equals 1/3 big B times H. So now we know our big B, which was that 41.568. Then we need to multiply by our height. What's our height on this picture over here? 10. It's the piece going straight up. It's perpendicular to the base. Now we can type this in and get our true final answer. 138.56 is what I've heard in inches cubed. There we go. That's much better. Now we're ready to start our cone formula, and it does start off the same way as the previous pyramid formula. However, we have a way to simplify it to make it a little easier to use because we know the area of the base. This base over here is a circle, so instead of writing big B, I'm going to write the area of a circle. And this is the formula we're going to use for cones. It's much faster. So now we're ready to try out these down here. Now we have two different types of shapes. One is a right cone, one is oblique. Oblique means that that vertex is not directly up above the center of the base. It means it's just kind of leaning over here to the side a little bit. However, these are both solved in the same manner, so we're only going to do one of them. All right, so do we want to do A or B? A. All right, we're going to do this one right here. So once again, our formula is volume equals 1/3 pi r squared times h. Now the good news is we have everything we need. We don't have to do trig or Pythagorean theorem because they help us out. Pi, what's my radius over there? 9.5 squared times our height, which is 16.8. So really this is just, can you type it in the calculator? Try it out. 1,576. Is that right? So what are these numbers? 87 here. Okay. And millimeters cubed. On example 3, they give you a little bit more work to do because they don't give you a radius. On this one, you got to solve for radius by realizing that this makes a right triangle. So they drew the right triangle out to the side, and that's a good practice. They're not going to draw this out to the side for you on the test or the quiz, so you got to be able to do that yourself. The only other thing we need to add is r, because we need to solve for r. So once again, this is going to be a trig problem. We can't use special right triangles on this, but trig will definitely work. So to figure out our trig, we need to label. Across from the angle is our opposite, and beside it is our adjacent. Opposite and adjacent is what trig? Tangent of the angle 62 equals opposite, which is 12, over adjacent, which is r. And now we can cross multiply just like we did earlier. 12 times 1 is 12. And now we're ready for our other cross. That's going to be tangent of 62 times r. Now we have to remember, we're trying to get r alone. To get r alone, what do we need to do? Divide by tangent 62 on both sides. When you do that, these cancel. We're left with r. And on the left side, we get 6.3 is what I heard? 6.8? 6.38. Now, since we have our radius, we can plug into our volume formula. And I'm just going to kind of borrow what they have over here. I'm going to kind of fill in the blanks. So inside the parentheses, well, we already have our pi. Now we need our radius squared. Our radius we just found is 6.38. We're going to plug that in. And then we need our height. What's our height? Oh, it's over there in the original picture, 12. So now, if you can type this in, you'll get, so I heard 511.51, and those are meters cubed. This next problem is called a complex solid or composite solid because it takes two solids and sticks them together. Now in the past, when we did surface area on a problem like this, we actually had to cut out this piece where they're stuck together because we're talking about wrapping paper and we only want to wrap the outsides of figures. But now when we're dealing with volume, we're trying to think how much stuff can we fit inside. So we actually want all the volume of each shape, and we're going to put them together at the end. So we have two shapes up there. You got to realize that first. The shape on the top is called a cone. So what's the cone formula? It is a right cone. So volume is 1/3 pi r squared times h. There's our cone. The other shape is what on the bottom? A cylinder, and that is pi r squared times h. Now in my opinion, this problem is not hard because it gives you a lot of the information you need. Let's start off with the cone. We know it's 1/3 pi, but now we need our radius. So we got to look over at the picture. The radius is up here. They don't draw it right here. However, you can transfer this one from the cylinder straight up, and it's also 3. Our radius is 3. After that, we need our height. What's our height on that cone? It's also 3. We're going to pause there for a second, and now we're going to jump down to our cylinder. So that's pi. What's our radius of our cylinder? We said it was 3. And what's the height of the cylinder? It's a 7. The whole cylinder is a 7. So my advice is to add these two things. So you're going to type in this part plus this part directly in your calculator. That way you don't need any intermediate rounding, and see what you get. Alright, so we get 226.19, and the units on it are going to be centimeters cubed. And that comes from adding these two parts right here and getting our answer without any intermediate rounding. Try out these checkpoints, see how you can do on 2, 3, and 4. So number 2 is the first one we're going to start on. What you should realize is we need our regular height. To find that piece, we got to use Pythagorean theorem. That's going to be 10 squared equals 6 squared plus 8 squared. Well, I remember these numbers because they're all multiples of Pythagorean triple, which is 3, 4, 5. So this is going to be a height of 8. You could solve that and find 8 as well. Now we're ready to do our volume formula. That's 1/3 pi r, which is 6 squared, times h, which is 8. When you do that, you should get what? 301.59 feet cubed. That's a good answer right there. Number 3, a little bit more challenging. You got to use some trig. You should picture this right triangle and see that this piece is our opposite and this is our adjacent, or our height. We can do trig with opposite and adjacent. That trig is tangent of 32 is opposite over adjacent. How big is that opposite piece? 7. It's half of 14. Over our adjacent, which we don't know, we're going to call it h for height. Cross multiply. 7 times 1 is 7. Tangent of 32 times height. How do you get height alone? Divide by tangent of 32 on both sides, and you're going to get your height is what? Now we're ready to plug into our formula. So we have volume equals 1/3 pi, our radius is 7, square it, times our height, which is this piece right down here, 11.202. When you multiply all those, what do you get? 574.8 is what I heard. Okay, so be careful. I don't know if that's 0.7 or 0.8, so be careful with your rounding. Now we're ready with number 4. This is maybe the most challenging, but if you remember these shapes, it's not that bad. We have a cube, and it has a cone cut out of it. So first we're going to find the volume of a cube, and that's really easy. You do side cubed. So the side is 5.1, and we're going to cube it. What do you get when you do 5.1 cubed? 651. All right, now we need to do the volume of the cone. So that's going to be volume equals 1/3 pi r squared h, what is our radius? Well, if you transfer this piece up to right here, or transfer this down, it's going to be half of 5.1. Half of 5.1 is 2.55. And our height is going to be how far it is from the vertex to the center. That's also a 5.1. If you type this in, did anybody already type that in? Now, all we need to do is realize that this cone is cut out from the cube. So you take this number and subtract this number to get our final answer, which is like 97.923, and the units are going to be meters cubed on volume.